Do you know what's the front and what's the back? What's the anterior, what's the posterior?
These little horns that go up higher are on the back, and the twosie poozies are on the front.
Okay, you can do that. Or you can try to find this thing. This is the
Bulge.
dorsal root ganglion.
And it's a
The
bulge.
dorsal root ganglion is only in the dorsal aspect of the spinal.
I like my twosie poozie thing on the front.
The dorsal root ganglion is also here and here. But that's also accurate. You could use that. But this one's easier to find on most of the models.
So that's the front.
This is the
Back.
Oh, the
back.
back.
This is dorsal root, like dorsal fin on a shark.
Okay, gotcha.
So this is the back. So if you already identify your dorsal root ganglion, then you know this is a ventral root, this is a dorsal root, these are rootlets, but they're still named dorsal and ventral. Then you can start looking at the horns. Now you know this is dorsal, so this horn has to be dorsal. If this is a dorsal horn, this must be the anterior or ventral. If these two are dorsal and ventral, this one must be lateral. The two sides are connected by this gray tissue called the gray commissure. There's a hole in the middle, and that's called the central canal. There's cerebral spinal fluid in that canal. If we know that this is a dorsal horn, what can we say about this fasciculus or funiculus? That just means the white matter. Can we name it? Dorsal, funiculus. This one?
Ventral,
Ventral, and then this one's
lateral.
lateral. So right there alone, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11
Vocabulary.
things I could stick stickers on, and their vocabulary words.
Okay,
And they're all
can you say
dorsal.
what the gray commissure was again?
Yeah, sure.
The great
Where they're
buds.
connected together, so here, where the butterfly wings are connected together, the body, that's the gray commissure. It allows the right and the left spinal cord sections to talk to each other.
Okay.
And what's the rami communicanis? My line is for. So, what is the communicating
So I
rami?
think that's what these little guys are.
It's the two on the bottom, and does it matter the front and the back, or do they?
Well, these are going to go posterior or dorsally. These are going to extend ventrally. And what you'll see is that these rami on the ventral aspect are bigger because it's got to come all the way around and do the rest of the body. The ones on the back, the dorsal ones, they only have a little bit of muscle and skin to take care of in the back. So we don't need to be as extensive.
So there's a touch, and the rootlets are basically under the myelin sheath part, the wrapping part.
These little guys are rootlets.
I know what's wrapping the skin. I mean, not skin, but like what's that?
Connective tissue.
Okay.
So, one of the neat things about the spinal cord is all sensory comes in from the dorsal aspect and synapses in that dorsal horn. All motor comes out from the ventral aspect. So this is all motor. This is all sensory. When you get them back here, they're now mixed. They're both sensory and motor because they're mixed up. All that sensory information is coming in. Synapses at the cell bodies are here in the dorsal root ganglion. They come in and they synapse at the dorsal horn.
What was the lateral funiculus again?
Lateral funiculus is the lateral white matter. The lateral horn is only necessary for the sympathetic nervous system. And it's only found in the thoracic and the lumbar region. So not all of your spinal cord models will have a lateral horn.
Do you have one that doesn't have one?
That one doesn't have much of a lateral horn. This one. So the problem here is the dorsal root ganglion got snapped off. If you have the model house, you probably have the picture of it. This is the ventral horn. This is the dorsal horn. This is the ventral horn. This is the lateral horn. There's not much of it, but it's there, just a little bit. I like this model because it also shows you the meninges. So the pia, then there's the arachnoid, then the dura.
Can you say that again?
Pia. Can you see it at all? You can
No,
see
but
it.
I
Arachnoid
got it.
and dura. Let me try
And
it.
then the subarachnoid space in between and the.
Yep, space in here. is a subarachnoid space. So, pia,
And subdural.
arachnoid, dura.
Okay.
Subdural space, you're not seeing much. It would be in between the arachnoid and the dura. This is the epidural space. You see all these blood vessels.
So this is pia, arachnoid, and dura.
Nope,
Pia right here,
yep,
arachnoid.
nope.
Right
And-
here, this thing.
Just this layer in the
Oh,
inside.
the layer on the inside and the
And
outside
then
of
this
the
is dura.
dura, and the inside is the dura matter. The subdura space.
If there was a space between the arachnoid and the dura, then that would be the subdural space.
Subdura, and this is the subarachnoid space in
Yep,
here.
so this is arachnoid space,
All the way around.
and that's where the
Dura,
CSF is.
and arachnoid.
So here, if you look on this side, it's pia, arachnoid, dura.
And this is called the same as like the brain, it's the fissure, that line in between the two.
Yeah, this one is simply the dorsal or posterior fissure, might even call it sulcus, and then this one is the ventral or anterior.
And what else do you use in the, of this guy, or just this part? So any of this part, this is the bones, we're not studying that in this quiz.
This one actually has a sympathetic chain ganglion as well.
Where is that?
Chain ganglia, chain ganglia, chain ganglia, chain ganglia. But I wouldn't use this one. I'd use that pink model.
Can we look at stuff on that one?
And what are these, the ventral, these are blood,
Those are blood vessels.
okay. But
These
what
are
else, but
vertebral
mostly for
arteries.
this particular model, we're studying this.
Yes. That's what we're interested in.